Okay, so what is the value of 2 to the 1/3 now? And before we get into this, let's think about this, okay? So for now, let's think about this. So you guys think about this, how are we gonna handle this? So pause the video and think about this now. Okay, so to understand this part, we can now go back to what is the 2 to the 1/2 power? Well, we said this was close to, we estimated like a 1/5, remember? And then it turned out from the calculator, the graphing, we know it's close to actually 1/4, right? So this is a better estimation, actually. So let's look at the calculator. I'm gonna bring a calculator in. So let's see, so let's bring a calculator, turn it on. So I'm gonna actually get the value from the calculator to see how that works. So let's look at the calculator. So what is the square root of 2 equals to, if I go enter, so we know it's gonna be 1.4142135562, right? So what is the value of, let's compare that to 2 to the 1/2 power. So if I go enter, so you can see that from the screen that it's the same value, exactly same value, right? Okay, so this tells us, I'm gonna leave the, okay, so this tells us that remember that the 2 to the 1/2 power is equal to square root of 2, right? That's what we saw in the calculator just now. Because square root 2 times square root 2, which I can compare that to what we just did in the 1/2. So that's the same thing as 2, right? Because we know square root 2 times square root 2 is equal to square root 2 squared, right? Because you got 2 copies of it. And that, you can see the square root and square, they undo each other. So this is equal to 2 now, right? So we know square root 2 times square root 2 is a 2. But we also know that 2 to the 1/2 power times 2 to the 1/2 power is equal to 2. Remember this? So this tells us, why is that? Because if the base is the same, you add the exponents, right? The 1/2 plus 1/2 is equal to 1, so that's the same thing as this, right? So this tells us that this right here, one number times another number is equal to 2, and you have another number times another number is equal to 2. So if this is true, then we can conclude that square root 2 must be equal to 2 to the 1/2. Because you multiply this twice and you got the same results, right? So we can conclude that one of these and one of that should be the same thing, right? So this is the conclusion we made. This is the one thing that you need to remember now. Okay, with that, we can continue with 2 to the 1/3 power. So using the same reasoning and strategy, and we can, what is this? Well, we can come back to this by doing this. So let's try this. So 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3 now should be equal to 2 then. So how do you know this? Well, since base is all the same, we can just add the exponents, right? Remember that rule we had, b to the mth power times b to the nth power is equal to b, the same base, and you just add the exponents, right? So we got to remember that rule. So using that rule, we can come back here. So what does that mean? Well, this means the base is the same, so we can leave the base alone, and that means exponent is all added together, right? 1/3 plus 1/3 plus 1/3. And that should be equal to 2. We're checking now, right? So what does that mean? Well, this means, since, look at the exponents, since base, well, I should say denominator, since denominators are the same, we simply add the numerator, right? So this same thing as 1 plus 1 plus 1 over same denominator 3, right? Common denominator. right? So that's equal to 2. So that means 2 to the, what power is it now? 1 plus 1 plus 1 is the same thing as a 3 over, now it becomes 3 over 3 on the exponents, right? Equals 2. So 3 over 3 is, we know it's 1, right? So we know this checks out. So that is equal to 2. So using the same reasoning, now we can say, then what is the 2 to the 1/3 times 2 to the 1/3 and times 2 to the 1/3 and becomes 2. So can we find the same number, these three numbers, right, equals 2? I'm using the same strategy that we just did for square root 2. So, well, we can think about this, right? Think about it. So we can say, what about the cube root then? Well, you can use the cube root, right? Cube root of 2, and cube root of 2, and cube root of 2 must be equal to 2 then. The same reasoning as the square root of 2 idea. So is this true? Yes, this is true, because we can say cube root of the 2, you got 3 copies of this, right? So isn't that the same thing as third power on top of it, right? And the cube root and the third power will just undo each other. So this will undo each other like this, right? And that must be equal to 2, because then 2 comes out. See? 2 comes out, so that's equal to 2. So that checks out. So what does it tell us? So same reasoning as, so this must be the same number. So these right here, this must be the same number right here, right? This number must be same as that, and this must be same as this, and this must be same as that. So that's why we got the same results as 2 and 2, right? So this concludes that we have 2 to the 1/3 now. So what is the exact value? Well, it's equal to cube root of the 2, right? So where are we going with this? Well, now can you think about this for next lesson? Can you think about then what is the value of how about 2 to the 1/4 then? How about 2 to the 1/10? And if this to generalize, think about then what about the number at the denominator is like nth? We make it generalizing it, so we can make a rule. So what is that equal to then? Well, let's think about this. Can we change it into radical expression then? That's a question for the next lesson. Thank you.